Hi, today we'll practice the homework questions that I gave you in previous class and we'll practice some assertion reasoning questions based on decimals. Let's start with the homework question. The question was, what should be subtracted from sum of 4225.5 and 6350.75 to get the greatest four-digit number? To find the answer of this question, first of all, we will do the sum of these two decimals. To the sum of these two decimals, first we'll arrange it in column-wise manner. So let's arrange. So now after arranging it in column-wise manner, we will do the normal addition of whole numbers like we do the addition of whole numbers. So here we'll same do it for decimals after arranging it in column-wise manner. 5 plus 0 is equal to 5. 7 plus 5 is equal to 12. 2 point under point, 1 carry over. 0 plus 1, 1. 1 plus 5 is equal to 6. 6, 5 plus 2, 7. 3 plus 2, 5. 6 plus 4, 10. So, the answer of the sum of these two decimals is 10,576.25. Now they are saying what should we subtract from this number to get the greatest four-digit number. First of all, you should know that the greatest four-digit number is 9,999. So they are saying that which number should we subtract from this number to get 9,999. Get 9,999, we will subtract 9,999 from this number. That result will be the answer of this question. So let's subtract. Here it's our choice. We can put zeros after the point if we want, because putting zeros after the point does not matter. So here I'll put zeros after. Now that we have arranged this column wise, now we'll subtract it. Here 5 minus 0, 5, 2, 0, 2, point under point. Here we cannot do 6 minus 9, so we'll take borrow from next digit. 7 will become 6 and 6 will become 16. Here 16 minus 9 is equal to 7. 7. Here we cannot do 6 minus 9, so we'll take borrow from next digit. Here 5 will become 4. 6 will become 16. So 16 minus 9 is equal to 7. Here we cannot do 4 minus 9, so we'll take borrow from next digit. The next digit is also 0, so we'll take borrow from the next digit. Here 1 will become 0. 0 will become 10. And here we'll take borrow from here also. So 10 will become 9 and 4 will become 4. 14 minus 9 is equal to 5. Here 9 minus 9 is 0 and 0 minus 0 is equal to 0. So the number to be subtracted from the sum of these two decimals to get the greatest four-digit number is 577.25. So the answer of this question is 577.25. Now let's practice some A&R questions. For all these questions, there are some 4 options. I will read out all the options. First option. If both statement 1 and statement 2 are true, and statement 2 is the correct explanation of statement 1. If both statement 1 and statement 2 are true, but statement 2 is not the correct explanation of statement 1. Statement 1 is true, but statement 2 is false. Statement 1 is false, and statement 2 is true. Based on these 4 options, we have to answer all the questions. So let's start. Statement 1 of question 1. Statement 1, they are saying, on subtracting 5 km 8 meter from 26 km 50 meter, the result will be obtained as 21.042 km. First of all, we will convert this 5 km 8 meter into 1 unit kilometer, because for adding or subtracting any units, we have to add or subtract in only 1 unit or the same unit. So here we'll make 5 km 8 meter into kilometer first. First of all, you should know that 1 kilometer is equal to 1000 meters. So now you know that 1 kilometer is equal to 1000 meters. So on base of this, first we'll convert this 8 meter into kilometers, and then we'll add the result into this 5 kilometer. So here, when we convert 8 meter into kilometer, the result will come 8 by 1000 kilometer. Here, because we are applying two formulas. First of all, we are applying 1 kilometer is equal to 1000 meter. And second, here meter is smaller than kilometer. And here we are going to bigger from smaller. So to going to bigger from smaller, we have to divide the number. And here we will divide the number by 1000 because 1 kilometer is equal to 1000 meter. So here that's why I divided 8 by 1000. So 8 by 1000 kilometer is equal to 8 meter. Here 8 by 1000 can be rewritten as, here look, because in the denominator there are 3 zeros. And in the denominator there is 1000 and in 1000 there are 3 zeros. So in the numerator we will shift the point 3 places to the left. So here first place, second, here we'll add 1 0 and 1 third. Here also we'll add 1 0 point and here 0 option. So that's why I wrote 8 by 1000 as 0.08 because the denominator there are 3 zeros. That's why I can write 8 by 1000 as 0.008 kilometers. So here 0.008 kilometers is equal to 8 meter. Now we'll add this 0.008 into 5 kilometers. So let's add. Here we can put zeros after the point because putting zeros after the point does not matter. So here I put zeros after. So here 0 plus 8, 8, 0 plus 0, 0, 0 plus 0, 0, point under point, 5 plus 0, 5. So 5.000 plus 0.008 is equal to 5.008. So when we convert 5 kilometer 8 meter into kilometers, the result is 5.008 kilometers. Now that we have converted 5 kilometer 8 meter into kilometers, now we will convert 26 kilometer 50 meter into kilometers. So first we'll write. Here we know that 1 kilometer is equal to 1000 meter. So on base of this, I can say that, because here I am saying that 50 meter is equal to 50 by 1000 kilometer. Because here we are applying that 1 kilometer is equal to 1000 meter. And here meter is smaller than kilometer. So here we are going to bigger from smaller. So to going to bigger from smaller, we will divide the number. And here we will divide the number by 1000 because here 1 kilometer is equal to 1000 meter. So that's why I divided by 1000. So here 50 meter is equal to 50 by 1000 kilometer. Now here 50 by 1000 can be rewritten here because in the denominator there is 1000 and in 1000 there are 3 zeros. So in the numerator we will shift the point 3 places to the left. So here first place, second place and third place. So here put 0, here point and here 0 optional. So that's why I can write 50 by 1000 as 0.050 because in the denominator there are 3 zeros. And here 0.050 can also be rewritten as 0.050. 0 at the end of the decimal does not matter. So that's why we can write this 0.050 as 0.05. So here 0.05 kilometer is equal to. Now we'll add this 0.05 kilometer in 26 kilometers. So let's add. Here 0 plus 5 is equal to 5. 0 plus 0 is equal to 0. Point under the point. 6 plus 0, 6. 2 plus 0, 2. So 26.00 plus 0.05 is equal to 26.05. So when we convert 26 kilometer meter into kilometers, the result is 26.05 kilometer. Now we have all units in kilometer. Now we will subtract 5 kilometer 8 meter from 26 kilometer 50 meter. 2605 minus, here we'll write 5.008 because here from this subtracting this 5 kilometer 8 meter and here 5 kilometer 8 meter is 5.008 kilometer. So minus 5.00 kilometer. Here we'll put a 0 at end. It's our choice. We can put or we cannot put because putting 0 at the end of the decimal does not matter. So here we cannot do 0 minus 8. So I'll take borrow from next digit. Here 5 will become 4. 0 will become 10. So your 10 minus 8 is equal to 2. 10 minus 8, 2. 4 minus 0, 4. 0 minus 0, 0. Point into point. 6 minus 5, 1. 2 minus 0, 2. So 26.050 minus 5.008 is equal to 21.042. Ours is coming 21.042 kilometer, and here's also coming 21.042 kilometer. So here statement 1 is correct. Now let's see statement 2. 26 kilometer 50 meter and 5 kilometer 8 meter can be expressed in kilometer as 26.500 and 5.080 kilometer respectively. Here they are saying that 26 kilometer 50 meter kilometers 26.500 kilometers, and here our result is coming 26.05. So there is much difference between 26.500 kilometer and 26.05 kilometer. So here in first half statement itself, their statement is wrong. So this whole statement is wrong. So the correct answer of question 1 is option C, which is if statement 1 is true but statement 2 is false. Statement 1 of question 2. Statement 1. On simplifying 40 plus 1 plus 1 by 10 plus 9 by 100 plus 2 by 1000 minus 5.193, we get 35. They're saying when we simplify this whole expression, we get the result 35. So first let's simplify. So before simplifying, first we'll convert these fractions into the decimals. First let's convert 1 by 10. So here by 10. So here in the denominator there is 1 0. So the numerator will shift the point one place to the left. So here one place, here point will come, and here 0. So here 1 by 10 can be written as 0.1 in decimal form. Now let's convert 9 by 100 to its decimal form. Here in 9 by 100 in the denominator there are 2 zeros. So in the numerator of 9 by 100 we will shift the point 2 places to the left. First, second. Here we'll put 1 0, here point, and here 0. So 9 by 100 can be written in decimal form as 0.9. Now let's convert 3 by 1000 to its decimal form. Here in the denominator of 3 by 1000 there are 3 zeros. So in the numerator of 3 by 1000 we will shift the point 3 places to the left. So first place, second, here we'll put 1 0. In the third place, here also we'll put 1 0. Here point 0. So when we write 3 by 1000 in its decimal form, the answer will come 0.003. So now we have all the fractions in their decimal form. So now we'll add the expression. So first we'll add the whole number part of the expression. First we'll solve this part of the expression. We will minus this number later. So first 40 plus 1 is equal to 41. I'll write 40 plus 1 is equal to 41. Now in 41 we will add the sum of these three decimals. So first we'll do the sum of these three decimals, then we will add the sum in 41. First we'll do this sum. Here 3 plus 0 is equal to 3. 0 plus 9 is equal to 9, and 9 plus 0 is equal to 9. 0 plus 0 is equal to 0, and 0 plus 1 is equal to 1. Point into point, and here 0 plus 0 plus 0 is equal to 0. So when we do the sum of these three decimals, the converted form of these three fractions, the result is coming 0.193. So now let's add this result, which is 0.193 in 41. Here 0 plus 3 is equal to 3. 0 plus 9 equal to 9. 0 plus 1 equal to 1. Point into point. 1 plus 0 is equal to 1. And 4 plus 0 is equal to 4. So when we add 41 and 0.193, the result is 41.193. Now from this result, we'll subtract 5.193. Let's subtract. Here 3 minus 3 is 0, 9 minus 9 0, 1 minus 1 0, point under point. And here we cannot do 1 minus 5, so we'll take borrow from next digit. Here 4 will become 3, here 1 will become 11. So here 11 minus 5 is equal to 6 and 3 minus 0 is equal to 3. And here 36.000 can be rewritten as 36 because zeros at the end of the decimal does not matter. So here our result of this expression is coming 36 and here D result is coming 35. So here this statement 1 is wrong. Now let's see statement 2. Statement 2 is saying the decimal form of this expression is 41.193. First of all, before subtracting this 5.193 from this, we already calculated the decimal form. Decimal form was 41.193 and here decimal form is also coming 41.193. So here statement 2 is correct. So the correct answer of question 2 is option D, which is if statement 1 is false but statement 2 is true. Statement 1 of question 3. Statement 1. The sum of 27.8, 175.09 and 685.7 is 888.59. So first we'll do the sum of these three decimals and then we'll verify with their sum. So first let's write it. So let's add now. Here 9 plus 0 plus 0 is equal to 9. Here is 0 plus 7 is equal to 7 and 7 plus 8 is equal to 15. 5 point under point, 1 carry over. 5 plus 1 is equal to 6. 6 plus 5 is equal to 11 and 11 plus 7 is equal to 18. So here 8, 1 carry over. 1 plus 7 is equal to 8 and 8 plus 8 is equal to 16 and 16 plus 2 is equal to 18. So here 8 carry over. 1 plus 1 is equal to 2 and 2 plus 6 is equal to 8. So when we add these three decimals, our result is coming 888.59. And when they add the decimals, their result is also coming 888.59. So your statement 1 is correct. Statement 2. Subtract decimal numbers. We place them column wise correctly in the place value chart or table you can say and subtract them in the same way as of whole numbers. Here statement 2 is correct because they are saying that for the subtraction of decimal numbers, first we'll arrange it in column wise manner according to place value chart or place value table and then we'll subtract it normally like we subtract whole numbers. So here this statement is true. And here statement 2 is not the correct explanation of statement 1 because statement 1 is talking about addition and statement 2 is talking about subtraction and there is no relation between addition and subtraction. So your statement 2 is not the correct explanation of statement 1. So the correct answer of question 3 is option D, which is if both statement 1 and statement 2 are true, but statement 2 is not the correct explanation of statement 1. Question 4, statement 1. Statement 1. They are saying that 16.18 is greater than 16.082. So for the comparison of decimals, first we'll compare the whole number part. Here whole number part is same, here 16 and here it's 16. So now we'll jump on to the fractional part. Now we'll see the tens place. Here tens is 1 and here it is 0. So here 1 is greater than 0. So obviously this whole number is greater than 0. So your statement 1 is correct. Statement 2. Here they are saying that if the whole part in two like decimals numbers is same, here like decimals are the decimals which have equal number of places after their point. And here they are saying that if the whole part in two like decimal numbers is same, then the number having a greater digit at a 10th place is larger than the other. This is obviously true because when we jump onto the fractional part and in the 10th place we see that one number is greater than the other. So that means the whole number is greater than the other number. So here statement 2 is also correct. And here statement 2 is the correct explanation of statement 1 because your statement 1 is saying that 16.18 is greater than 16.082 and your statement 2 is justifying it by saying that if the tens place is larger in that number, that means the whole number is larger. So here the correct answer of question 4 is option A, which is if statement 1 and statement 2 are true and statement 2 is the correct explanation of statement 1. Statement 1 of question 5. Statement 1. 0.7, 0.77 and 0.777 are like decimals. This statement is wrong because like decimals are the numbers which have equal number of digits to the right of the decimal point. And here one number is having one place, one digit to the right, the second is having 2 and the third is having 3. And here that's why this statement is wrong because of this what I said now. Let's see statement 2. Two or more decimal numbers having same number of digits in the decimal part are called like decimals. This statement is true because I told this just now. When after the decimal point there are equal number of digits or places, those two decimals or any decimals more than 2 or 2 are called like decimals. So your statement 2 is correct. So the correct answer of question 5 is option B, which is if statement 1 is false but statement 2 is true. Question 6, statement 1. Statement 1. They think that 16,060 gram can be expressed in kg as 16.6 kg. First of all, we'll write a statement, then we'll check it. Here, first of all, you should know that here I'm saying that 1 kg is equal to 1000 gram. And here, gram is smaller than kg. And here we are going to bigger from smaller. So to going to bigger from smaller, we have to divide the number. And here we will divide the number by 1000 because 1 kg is equal to 1000 gram. So here when we divide by 1000, so here we can say this is their statement. I'm just writing it. I'm just trying to prove it. Here 16060 by 1000 gram. So this fraction can be rewritten in decimal form as, so when I convert 16,060 gram to kg, the result is coming 16.06. And here dear result is coming 16.6 kg. So your statement 1 is wrong. And here how I converted from this fraction to decimal? Here in the denominator there were 3 zeros. So in the numerator I shifted the point 3 places to the left. So first place, second and third. So here I placed a point, so 16.06. And here I can remove the 0 because this 0 was at the end of the decimal. And zeros at the end of the decimal does not matter. So here when I convert this 16,000 kg, the result is coming 16.06. And when they convert, it is coming 16. So here statement 1 is wrong. Let's see statement 2. In statement 2, they are saying that 1 kg is equal to 1000. This is a basic statement, and I also told because we do all the conversions from kg to gram or gram to kg because of this formula. And formula is 1 kg is equal to 1000 grams. So this statement is correct. So the correct answer of question 6 is option D, which is if statement 1 is false but statement 2 is true. Statement 1 of question 7. Statement 1. Here they are saying that 724 hectogram is equal to 72.4 kg. Here you should know that 1 hectogram is equal to 0.1 kg. And to convert hectogram into kilogram, we just divide the value by 10. So here we are converting 724 hectogram into kilogram. So we'll divide the formula. Divide this 724 by 10 because the formula is to convert hectogram into kilogram, divide the value by 10. So 724. Here 724 by 10 can be rewritten as 72.4. Because in the denominator there is 1 0, so in the numerator will shift the point one place to the left. So one place here will be 1 point, so it will be 72.4. So here 724 hectogram is equal to 72.4 kg. My result is coming 72.4 and theirs is also coming 72.4 kg. So here statement 1 is correct. Statement 2. They are saying that 1 hectogram Hg is equal to 10 grams G. They are saying that 1 Hg is equal to 10 G. This statement is wrong because 1 hectogram is equal to 100 grams, not 10 grams. 1 hectogram is equal to 100 grams. So that's why this statement is false. So the correct answer of question 7 is option which is if statement 1 is true but statement 2 is false. Question 8, statement 1. Statement 1. Sum of 6.24, 1.48 and 2.28 is 10. So first we'll do the sum of these three decimals and then we'll verify with their sum. We'll write. So now let's add. Here 4 plus 8 is equal to 12 and 12 plus 8 is equal to 20. 0, 2 carry over, 2 plus 2 is equal to 4, 4 plus 2 is equal to 6 and 6 plus 4 is equal to 10, 0, point under point, 1 carry over, 6 plus 1 is equal to 7, 7 plus 2 is equal to 9 and 9 plus 1 is equal to 10. So when we add these three decimals, the result is coming 10.00 and here 10.00 can be written as 10 because zeros at the end of the decimal does not matter. So here our result is coming 10 when we add these decimals and when they add these three decimals their result is also coming 10. So here statement 1 is correct. Statement 2. Three or more unlike decimals can be added by making the decimal places in all the numbers same. This statement is also true because here they are saying that the three or more unlike decimals can be converted into like decimals. Look, when here let's imagine there are three unlike decimals. To convert them into like decimals, how much digits we need to convert them into like decimals? We will add that many zeros to the end of the decimal because putting the zeros at the end of the decimal does not matter. And here they are saying after converting into like decimals, we can add if we want and we can subtract if we want. And here this statement is also saying this. So here statement 2 is correct. But here statement 2 is not the correct explanation of statement 1 because your statement 1 is saying sum of these three numbers is 10 and your statement 2 is saying three or more unlike decimals can be added by making the decimal places same. So that's why statement 2 is not the correct explanation of statement 1. So the correct answer of question 8 is option E, which is if both statement 1 and statement 2 are true, but statement 2 is not the correct explanation of statement 1. Statement 1 of question 9. Statement 1. Here they are saying that 714.371 minus 54.21 is same as 714.371 minus 54.021. Here let's see. Here's 714.371 and 714.371 is. Now let's check the other number. Here the number is 54.21 and here it is 54.021. Here this is not same as this because here in the between of the decimal they added 0. Adding the 0 at the end or the start of the decimal does not matter. But adding 0 at the between of the decimal does matter. And here they added at the between of decimal and they said that these both expressions are equal. Here statement 1 is false because these two expressions are not equal. Let's see statement 2. Statement 2. To subtract two decimals, they should be first converted into like decimals. This statement is true because to add or subtract like decimals, first of all, if the decimals are unlike, or how many decimals they are, if they are unlike, we first have to convert it into like decimals, then we can add or subtract the decimals. So here this statement is also correct. So the correct answer of question 9 is option D, which is if statement 1 is false but statement 2 is true. Question 10, statement 1. Statement 1. The difference of 14.02 and 27.8 is same as difference of 27.80 and 14.2. First we'll write the expressions. Here first we'll check the first number. The first number is 27.8 and here it is 27.80. Here they have added the 0 at the end of the decimal which does not matter. That means these two numbers are same. Now let's check the other number. Here it is 14.02 and here it is 14.2. Here they remove the decimal which is in between. And when we add or remove the 0 in between of the decimal, the number is not the same. And here they removed the 0 in between of the decimal. So these two numbers are not same. That means the difference of these two numbers and these two numbers is also not same. And here they are saying that the difference of these two numbers and these two numbers will come same. So here statement 1 is false. Now let's see statement 2. Statement 2. Every fraction with denominator 100 can be written in decimal notation. This is true because in the denominator there should be at least 1 0 to write it into a decimal form. And here in the denominator is 100 and in 100 there are 2 zeros. So obviously every fraction with denominator 100 can be written as decimal form. So here statement 2 is correct. So the correct answer of question 10 is option D, which is if statement 1 is false but statement 2 is true. That's all for this video. Thanks for watching.